Are we supposed to be seeing it now?
Yeah, just a minute.
Oh, okay, thank you.
Okay. So just upload your quiz. Okay. Okay.
Mr. Pham?
Yeah.
I opened that quiz that you said was, it was 7, but it said 6, and it's actually for 6. 7 isn't up there.
You mean you open the report or what?
Yeah, I opened it and it's for 6. It's for transistor.
Oh,
Yeah.
okay. I will check it.
Okay, thank you. Transistor amp. Quiz 6.
Okay, so I see I get number 1 to number 16. And I could not see any wrong with that. Okay, anyway, we continue to get through the operation amplifier. And we will continue on the next transistor. That will be JFET. And that will be almost done. The next one will be talking about, the, let's see, um, active filter. We get 5 more weeks, and the last week will be the final. So basically, 4 more. Okay? So now, we're talking about inverting amplifier, right? Last time, we already done. This one we done or not? We already done, right? Inverting amplifier. Okay, for this circuitry. Okay, go ahead and do it. Hello. Yeah. Chào với lại tất cả. Ok. This one we done or not done?
Yeah, we did do it. It's not a bad review though. Ace.
Okay, now we want to get through it.
Okay.
Okay. I think that one already done it.
Yeah. We were done all the way up to.
Okay.
Let me see.
This will be unity gain and summing amplify. Okay. Slew red, I think we already done. Okay.
Yep. I think we were on the last 3 slides. Yeah. Yeah.
That one, we done or not?
No, we didn't do that. You talked about it a little bit about the signal being out of phase.
Oh.
On slide 35.
Right. 35. Right now, 29.
Okay.
30. 31. Okay, that's 35.
Right. That's where we stopped.
Okay, thank you. Next time, I have to take a note. Okay, basically, the different amplifier combine input, waveforms, and account for amplitude and the phase. If R1, R2, R2, R4, and R5 equal value, we already know Vout will be equal V2 minus V1. Okay, that will be telling you one thing. You get a different amplifier. Okay. Only thing is, make sure the input, okay, they have to be out of phase. Okay. Based on the circuit information, Vout equal. Can you do it to see what you get?
It'd be 2 volts, peak to peak.
You said Vout equal 2.
Oh, I'm sorry. Wait a minute. It's 0.
You said 0. That means B, right?
Right. Am I correct on that?
Well,
It's a C.
you said C. Well,
As we can see, they're out of phase. That's the first clue. So we would know that V out is equal to V2 minus V1. And they're both 2 volts, right? So 2 minus 2 is 0.
Okay, now, how do we solving this problem? Differential amplifier. So the first thing, you suppose to solving for V1 without V2. That means inverted amplifier. Okay? Inverting amplify the gain equal minus 10 divide 10. That means the gain is 1. Okay? So the V1 output will be equal minus 2. Right? Then now you're solving for V2 by rounded V1. Okay? So V2 will be non-inverted. And what the input here? 2 volt voltage divider. You get 1 volt here. The gain for non-inverting equal 1 plus F over R1. So 10K, 10K, that means 1. Okay? 1 plus 1. You get the gain will be, let's see, so V1 equal, okay, 2 volt time gain 1 and basically minus V1 out equal minus 2 volt. Okay? And second one, you have to working on round right here. So they inverted in non-inverted amplify the voltage here VA voltage divider V2 okay equal 10 multiplied by 10 divide now 2 volt time 10 divide 20. So VA will be equal 1 volt. Okay, and now the gain for non-inverted V2 equal the gain. The gain will be 1 plus RF over R1 1 okay equal 2 so V okay let's see V2 will be equal 1 plus 1 okay equal 2 so 2 times the gain of V2 is 1 right VA now V2 is 2 is it 2 so V2 is it equal 4 Fourth thing, I know for sure they cannot be that one. Okay? And they cannot be 2 or 3. The answer will be 4, let's see. Right here. Okay? That is the answer. Correct V2 and V1 are our phase. Therefore, input voltage are added. Okay? So, the answer will be C. Okay? So, that's the last one on the operation amplifier. Okay, so now we'll be learning the JFET. Okay, one my learning in the past, I can tell you, to understand either anything you want to learn, keep reading over, and over. Okay? So if you understand, then that will be keep, long time in your brain. Okay? JFET is a second amplifier. You already learned the first one, bipolar transistor, NPN, PNP. Okay? And basically, the bipolar is the current controller. Okay? And now we're learning one more. That will be a JFET. Okay? We'll see. JFET junction field effect transistor is a type of FET that operates with a reverse bias PN junction to control the current in the channel. Depending on their structure, JFET falls into either of two categories, N channel or P channel. First thing, you're using this symbol here for N channel. This the second one for P channel. And this basically a physical N channel and P channel. First thing, what the difference between N channel and P channel? And JFET get the input, we're going to get the drain and the source. Same thing, get, drain, and the source. So what the difference between N channel and P channel symbol?
The way the current's going or the way it enters the JF?
See the arrow.
Yeah.
Arrow for N channel going in. Arrow for P channel going out. The thing is when you're looking into JFET and you don't know N channel or P channel, then you cannot solve the problem. Okay? And the next physical here, okay, for N channel, that will be P side, and it will be an N channel. You get the drain, you get the gate, and you get the source. Basically, the current will be flowing out from the drain to the source. And P channel just the opposite, okay, of N channel. DC N channel. You understand? You get two parts to learn. First thing, any transistor will need a DC voltage to make it work. Okay? And the second one will be talking about amplifier. Okay? So I think we can get to meeting to get it done. Now, we're talking about DC bias for N channel. This is a VDD. Okay? Provide the drain to the source voltage and supply the current from the drain to the source. That means you can get a current flow here. VGG, that means VG right here. Set the reverse bias voltage between the gate and the source. Okay? The thing is that JFET will be reversed, so that has to be a negative for N channel. JFET is always operate with the gate source PN junction reverse bias. That's for N channel. Okay, the next one. Let's see what they're telling you here. This is the JFET, okay, N channel. They connect the meter, go to the base, okay, and connect the meter between the VDD and the drain resistance. So that will be telling you what? They will be telling you you can get a very high, okay, negative voltage VGS, and you get this is the current, okay? So the current will be small. And another one, okay, they will be, you see that one. This is the channel for electron flowing from the drain to the source. You see, they're very narrow, so that's why lead current. However, on that one, you can see the difference. A, this channel will be little bigger. So you see, the voltage VGS will be lower, negative, and the current will be higher. Okay? They say reverse bias of the gate source junction with a negative gate voltage produce a depletion region along the PN function, which extends into the N channel and thus increase its resistance by restricting the channel width. Okay, and this is the JFET you're working on level. Okay, get the drain and the source, that is the pin number. Okay. JFET DC bias continue. Okay, for that one, you can see the VGS here, lead negative. Then the current will be more. That means the channel here will be wider. Okay, let the current flow it. Now, we'll see the drain characteristic. First thing, this shows you the current ID. Current ID flowing from the drain to the source. Okay? And this will be the voltage VDS. That means the voltage from the drain to the source. Okay? And basically, at the point VP, they call a ping off voltage. If you're going up here, okay, and looking into the left, you can get IDSS. Now, and also from the point B to the point C, okay, this area, you can see at the VGS here, V from G to S equals 0, then you get a maximum current, what we call a IDSS. And this area, they call a constant current area. And at this point right here, okay, that means breakdown. We're not doing anything here. So when you're looking on the display, you can see on the bipolar, you get same thing. Okay, you can get the active region. Okay, and active region and cut off region and amplify, activate. Now, in here, any voltage VDS less than VP, then the JFET will be using at the ohmic area. That means like just a resistance. Okay? From here, VP to the cut off here, the breakpoint, they're using at the constant current region, and I current will be equal IDSS with VGS equal 0. We already showed you. Okay, one thing here. When you try to get, okay, the channel wider and the voltage VGS keep decrease to 0. If they equal 0, that means you get a maximum current. So basically, IDSS, that's the current when they build the JFET they given to you. You cannot make it up. Okay? However, at this point, okay, you have to understand also you get the VP, pin off voltage, also be given from manufacturer. Any VDS less than VP. So basically, the FET now working at resistance. Okay? Drain curve. That they explain to you about the curve we just given to you. The maximum drain current of the FET occurs when the gate source voltage is 0. Okay? That means gate to source voltage. That means the gate to source in here, 0. Then they get maximum current. That's what they call VGS. This is a G. This is a S. So VGS equals 0. You get this current, ID, SS. The drain current is almost constant in the region between VP and VDS maximum. If the drain voltage is too large, the JFET will be breakdown. Okay? JFET acts like current source when it's operating along the almost horizontal part of the drain curve between the minimum of VP and the maximum VDS. They're telling you from here to here, they working at constant current. The maximum voltage of VP equal pin off voltage. The maximum voltage VDS max equal breakdown voltage. Between pin off and a breakdown, JFET act like current source with the value of IDSS. IDSS stands for the current from drain to source with the shorted gate. That means with VGS equal 0, then you get a current equal IDSS. Ohmic region, the almost vertical part of the drain curve equal ohmic region. That equivalent to the saturation region of bipolar transistor. Okay? You understand, I graduated from University of Florida in 1980. That means at that time, they don't talking about much JFET, so I not quite understand. Okay? However, when I teaching, I have to do it at start 1985. So that's why I have to start over learning about JFET without understanding. You cannot take it. Okay? So that only learning from my is reading over and over. Okay? Remember that. JFET this is by a cutoff voltage. The value of VGS that makes ID approximately zero is the cutoff voltage. VGS off. Okay, what that means? When you get a VGS off, they're telling you ID almost zero. JFET must be operated between VGS equal 0 and VGS off. Comparison of pin off and a cutoff. VP is the value of VDF, which the drain current becomes constant and is always measured at VGF equal 0. VGS off and VP are always equal in magnitude, however, will be opposite in size. A data sheet usually will given either VGS off or VP, but not both. We'll see.
Can you tell us just a little bit more about the data sheets?
The data sheet. What do you mean data sheet in here?
Yeah, on the bottom line there, it says the data sheets and the information that
Oh, that means when they bill, they give it to you. Either one.
Okay,
Okay?
yeah.
Not both VGS off or VP. Let's see. That's VP right here. Okay? Ping off voltage. That will be telling you. Okay? VP or ping off voltage will be the same value. Okay? Only the difference will be the side. Okay? Positive, negative. So that's why when they given to you the JFET, they bill, they given you either VP, then you have to know VGS off. Okay? Or ping off voltage. They just different the side.
Thank you.
Now, if you're looking into here, the display, that again stand for ID. On the other side, stand for VDF. Okay? Now, we already understand at the IDFF, that means the maximum voltage given by JFET and VGS equal 0. Now, if I get the point here, so at the point A, what the VGS equal?
-2.
Negative 2 volt. At this point here, you can going down to get the VDF, right? Okay?
Yeah.
And you can go to the left you get the ID. Exactly the same in bipolar. They call a Q point. Okay? So if you get any different point in here, okay, you can get a different VGS. So at this point here, VGS will be higher than this one. So for the JFET, they will be telling you this is voltage controller. Okay? The thing is you change VGS, you change the current ID. However, in the bipolar, same display, but that will be a IB. You change IB, you change the current IC. Okay? That bipolar will be current controller device. However, on JFET, you changing VGS, they changing current ID. So that will be current voltage divider, voltage controller. Now, once they connect to VGG, measure the voltage here. Once you connect the meter at the current of the ID. Okay? So now in here you can see no electron moving from the drain to the source. Okay? So the current measure will be 0. Okay? And the VGS, that means the maximum VGS here, go equal, that will be VGS off. Okay? Now, remember, at the VGS off, what current ID equal? ID equal 0. Okay? Or at the current ID equal 0 and the VGS, that means from a G to S, will be equal VGS off.
And so conversely, when the ID is at maximum, then VGS is at 0, correct?
Right, correct.
Thank you.
Now, the basic operation of P channel is the same as N channel device, except that P channel require a negative VDD and positive VGF. So basically VDD now will be negative, and this VGG will be positive. Okay? N channel will be opposite. So that's why normally they're talking about N channel. If you understand N channel, you can working on P channel. Example. For the JFET circuit show, they given VGS of minus 4 volt and IDSS equal 12 milliamp. They want to know the determine minimum value of VDD required to put the device in the constant current of operation. Okay? And this is the solution. Since VGS of equal minus 4 volt. Okay? VGS of equal minus 4 volt. Then VP equal 4 volt. Okay, now, like I just talked to you, VGS off and VP, that means pin off voltage. All the time they equal. However, they must be opposite value. And this voltage will be given by manufacturer, okay, not you. So, in here they say you get VG off equal minus 4, and you know VP equal 4 volt. The minimum value of VDS for JFET to be a constant current area is VDS equal VP. We already telling you right here. Here, that's a pin off voltage VP. That's a minimum for the constant current area. Okay? Okay, let's see. For the JFET to be in constant current area, VDS equal VP, 4 volt. In the constant current area with VGS equal 0, ID equal IDSS equal 12 milliamp. Again, IDSS also that current given from manufacturer. For each different JFET, the drop across the drain resistor RD, EVRD equal ID times RD will be 12 times 560 ohm. You get 6.72 volt. Apply Kirchhoff's law around the drain circuitry. You can calculate VDD equal VDS plus VRD. That means 4 volt plus 6.72 volt. That equal 10.7 volt. You need to go over, okay? JFET transfer characteristic curve.
Okay, can we go back to that last one for a second? Okay, so just so I'm understanding this, it's talking about applying Kirchhoff's law around the drain circuit. And so
Yeah.
that 10.7 volts is what's actually going through from the drain to the source.
That means VDD right here, right? Supply the current for that guy. Okay?
Yeah.
And also from here to here.
Do that again for me. From
Okay,
where?
that will be D. Right?
Right,
That will be F.
right.
Okay? So VDD supply for the voltage here. VRD. Correct?
Right.
And also here. VDF. So that's why they say the Kirchhoff current law. That means VDD equal the voltage drop around VRD. And the voltage drop VDF. Okay, that means the current go to RD and the current going from the drain to the source.
Would be
Okay.
10.7 volts.
They have to be VDD. Now you want to calculate that voltage here. They're not giving you any value. Okay?
Right.
However, in order to get that value, then you must know what the voltage drop across RD
Right. Okay.
and the voltage from D to S. So VDS, okay, equal 4 volt. Okay? That means the drain to the source. And VRD, they will be telling you right here. Okay? You get ID time RD. ID, you know that must be ID at X maximum current time the value ID. Then you adding into here. Okay? VDF, the drain to the source. Okay, transfer. JFET transfer characteristic curve for N channel. Okay, this stands for ID. This stands for VGS, but negative for N channel. They will be go positive for P channel. Okay? You see, ID equals 0 right here. ID equals 0. Okay? When VGS equals VGS off, that means at this point here, VGS, if you want to looking for ID, you go into here. You see ID 0. And ID equal ID at F. Now I pick 1 point here and 1 point here. At 1 point A here. Okay, if you get ID, you go into ID. Okay, so ID. Okay, if you want to get the VGS, okay, they telling you, you go to this point, VGS will be here, okay? So that's what they call VGS off.
So again, when IDS is at maximum drain current, then VGF or VGS is 0. And when
Right.
ID is 0, VGS is off.
Exactly. That's what they tell you.
Right.
Okay? So at the ID at VGS will be 0. At the VGS of ID will be 0. Okay? We get through that one quickly. Then we will be stopped. Okay? So now if you're looking here, they display. You see, that for ID. And this will be ID at ID at VGS must be 0. Okay? We'll see. Example, when VGS equal minus 2. Minus 2 right here. So you get a point here. Okay? Then if you want to looking for ID, you go to the right. This is the point. Okay? For ID. So ID equals 4.32 milliamp. A JFET transfer characteristic. That means the formula to calculate ID. Okay. ID equal ID SS time 1 minus VGS divided to VGS of square. Okay. That will be using if you want to calculate the ID. Okay. So I hope you spend a little more time, okay, to reading over and over and over. The thing is, JFET been using more than bipolar transistor, okay? The thing is later on, you can see the JFET will be get the very high input impedance, okay? So, up to that point, you get any question, anything? No?
No, not for me.
Okay. Let's see.
But I do still have a concern about the form that you're saying is to be used for the uh quiz, because
Okay.
it's
I-
for I filled that out for quiz 6. It's the same
Okay,
thing.
just a minute.
It's for transistor amp.
Okay, I'll show you uh, the quiz, right?
Yeah.
Just a minute.
Okay, thank you.
Okay, let's see. You see that?
Yeah, but I'm not seeing it quiz 7. Okay, on your file is labeled quiz 7, but whenever I go to the website, I'm not seeing it.
Okay. EDT.
Can you post that?
Yeah. I'll show you.
Oh, it's there? Where is it?
Okay, that's from website.
Yeah, I'm there now.
Here.
Oh, it's on the, okay, I'm looking at, let's see, you're going handouts. Okay, maybe I'm on the wrong page. Oh, okay. Okay, I was on home. Thank you.
Okay, and basically, quiz report, and only that instructor will be helping me to do whatever I need. Okay?
Okay, thank you so much for.
Yeah, you're welcome.
Okay.
And the question to me.
No more from me.
Okay.
Anybody else?
So I said, you want to be a good technician, or you want to be a good engineer later. Then this thing you have to really understand. Okay? The thing is sometimes the teacher is not good. That means he can understand the thing, but he don't know how to help your guy to understand. That's what I hit all the time. Okay? That means instructor talking about the subject, I couldn't follow it. Maybe that's my problem. However, when I have to do, I keep reading over. Up certain point, I understand. Okay? So, try to upload your quiz. Okay? As soon as you can. Okay? If no question. So, everyone will get a good weekend. And good night. Bye bye.
Thank you. Have a good night.
You're
Thank
welcome.
you.
Bye
Good
bye.
night.